Hello everybody, welcome back to my channel. And for today's video, we will talk about KNN. KNN stands for K nearest neighbor. What is it? This is the definition for it. It is a non-parametric supervised learning classifier which uses proximity to make classifications or predictions about the grouping of an individual data point. Now, to simplify this definition, which is taken from IBM, credits to that, I would define it like this. Uh, let's say you have a point, and around that point, there are a bunch of other points or classes. Now, which class is nearer to this point? That is what KNN does. Now, that's the simplified version of the definition. Now, let's move on to the next subtopic, which is what is supervised learning. I've used this term in the definition. Now let's understand what is it. Now let's take a small example. Let's say this is a triangle. Of course, it's a triangle, and you have a square, and this is a dictionary. Okay, and let's say you have a circle. All right. Now this data is going to be my input data. All right. So I've given the shape and the name of the shape, which is what for now, it's correct. We know that. Now I would send this to a supervised learning, and that is going to be here, supervised learning model. All right. And after this, I would send the data to, oh, I would send just a second, send the data to a predictive model, which is this predictive model. All right. So what exactly is happening here is in supervised learning, we basically provide the input and output, and then we train the model based on this inputted data. After that, we expect a predictive model for new data or the same data whenever you draw it, however you feel like. So that is what supervised learning is. Now let's go ahead and talk about the KNN part. Now let's assume that this entire canvas is our what do you call this? A graph or something? Not a graph. What is it? Axis. I can just call it a canvas for now. Okay. This is going to be your x-axis, and this is your y-axis. Oh, sorry, y-axis. Okay, and this is your origin, which has 0, comma 0 coordinates. Now let's take in few points. Okay, let's take a circle and 1, 2, and 3. Okay, let's take 3 for now. And let's say I have this is one class. Okay, this is one class. Let's take one more class. 1, 2, and 3. All right. Now let's take an arbitrary point for which I have to find out. And for the arbitrary point, let me color grade it to this. Just a second. Yeah, doesn't look good at all, but yeah, there you go. Now, yeah, let's take red. Okay, sorry, let's take red, do that, and your blue color, and let's just group it out here. Perfect. Now this is your class 1, and this is your class 2. All right. Now let's draw some perpendiculars from our center of arbitrary to a center of one of the element of each class. Okay, you do that, you do this and this. Likewise for class 1, that, uh, sorry, that and that. Of course, it should be perpendiculars, just for, excuse me for that. Now let's name each point as whatever you want. Let's keep it as orange for now. Okay, you have D1, D2, D3, D4, D5, and D6. All right. Now keep this in mind and let's try to find the distance. How would you do that? You can't use a scale all the time, right? So for that, there is a formula called Euclidean distance formula, and Euclidean distance formula. It goes something like this. Uh, Let me use a different color. So you have x2 minus x1 whole square plus y2 minus y1 whole square and a square root for the entire thing. Now, this formula will give you the distance between your arbitrary point and your individual class. You have to do it one by one. Now, let's assume for our argument's sake that D1 has the shortest distance and D6 has the longest distance. All right, let's go ahead and visualize that. Use purple, right? So let's go ahead and pick purple. Um, let's go. Sorry. Yeah. So we have 6 points. So one, two, three, four, five, and six. Okay, and we use red and blue. So let's go ahead and pick some red. No, sorry. Red. Erase this. Yeah. One, two, three, uh, four, five, and six. All right. So let's just draw the lines here. All right. Perfect. Now we have D1, D2, D3, D4, D5, and D6. You guys can also draw along and figure, like, learn together. So now let's take an arbitrary line. Let's not use highlighter. Let's pick, which color should I pick? Let's take green. Now let's just draw a line, dot a line at the center, and let's name it as, and let's take the value of k as 3. Now, from where did this k come? Now, the meaning of this k is it represents the number of neighbors. P-O-U-R-S, I guess. Yeah, yeah, neighbors, correct. So this is what exactly actually happens in k nearest algorithm. Now let's look at some few new terms. There's something called underfitting, overfitting, and balanced. All right. Now to do that, let me show you an example. Okay. Let's take orange. Oh, never mind. All right, and here let's take this. Okay, and the same thing. Let's select. Let's take the same thing. Just a second. Okay, now let's draw one more green. Okay, one, two, three, four, five, and here one, two, three, four. Let's put five, six, seven. Doesn't matter. And another one more third set. One, two, three, four, five, and green. One, two, three, four, five, six. No problem. Now let's try to separate these. All right. How do we do that? In the first case, let's be very, very precise. All right. You go here, you go down, you go there, you go there, and that. You separated it. Now, for second case, let's just draw a straight line. All right. I mean, it's not supposed to be there, but yeah, this looks better. And for this, let's draw a curved line. Let's an arbitrary line. Uh, just an arbitrary line that separates both of them. Now, for the first case, for the first case, here for the first case, it's called overfitting. Sorry, this is because our k value is it small or big? Can you guess? If you guessed small, you're right. Our k value is small. And for a second case, our k value is big. And for a third case, our k value is balanced. Balanced. Yeah. Oh, spelling's right. Balanced. Yeah. Perfect. And there are two more points. Now, there is something called bias. So here it is low bias and we have high variance. I'll just keep it VAR just for your understanding and simplicity. Whereas in the second case, we have a high bias and we have a low variance. Whereas in the third case, your variance and your bias, you have moderate bias and you have moderate variance. I mean, the symbol is used for moderation. I mean, average. Okay. So this is basically what is happening in the k nearest. Okay. This is how you can how your k value change like based on how you change your k value, your separation of data points will also vary. Now, let's talk about some advantages and disadvantages of utilizing k nearest neighbor. All right, so let's use a little bit empty space. Okay, you have some advantages. Why did this become advantages? And you have some disadvantages. Disadvantages. All right. Under disadvantages, we have the very first point, which is you cannot utilize KNN for big data sets. All right. And the second point is KNN cannot handle missing values. It cannot handle missing values. Now, for your advantages, it is very, very easy to implement, and like you just saw before, you will not need to train. So there is no training period. No training period for this. All right, these are the two main important advantages and disadvantages for your K nearest neighbor. Now, let me show you a very, very simple code snippet of how you can utilize this for your iris data set, because iris is very, very commonly used. So let's go ahead and pick that. It's barely three, four, 5 lines. I'll show it to you. Uh, you can start off by importing scikit library. So from sklearn, sorry, sklearn, you import neighbor neighbor dot data set datasets, and after that iris equals to dataset dot load iris. This is your uh, dataset name. Okay, your all right, and then x equals to iris dot data, and we're going to pick only the first two features. That's why you have a 2 here. And for your y, you take iris dot target. Perfect. After that, you will have to mention the value of k. So neighbor, I hope the spelling's right, but yeah, dot k neighbor classifier classifier, and this is where you mention your k value, n underscore neighbor equal to 5, and then clf equal to no, not equal to, clf dot fit x comma y. So here is a very, very basic code snippet for utilizing your k nearest neighbor and classifying your iris data set. So I hope you guys have understood exactly what KNN is and what it does and how it works. In case you guys have any other queries apart from, and it doesn't matter, if you guys have any other queries, please feel free to drop it in the comment section, and I will definitely get back to you and make sure your questions are answered. Have a nice day and see you next time. Bye bye.